Hello, this is Mr. Wynn, and today's video will be about graphing quadratic functions. First, make sure you know that a quadratic function has the greatest exponent of 2. Standard form for a quadratic equation would be f of x or y equals ax squared plus bx plus c. And in that, there are terms. The thing with x squared is called the quadratic term. The thing with just a regular x is called the linear term. And the thing without any x's is just the constant term. Alright, y'all know that a quadratic turns into a parabola, which is just a U shape. So, know how to graph an equation by making a table. You can always, no matter what, plug in x's to find the y's. So if I plug in 0 for x into the equation, well, that'll be 3 times 0 squared minus 12 times 0 plus 6. And if I simplify that, I get y equals 6. So my point is 0, 6. I'll put a dot there. 0, 6. Alright, now I do the next one. I put a 1 in. Well, when I fill it in and simplify, I get negative 3. So my next point would be 1, negative 3. Put a dot there. I could try plugging in 2. I plug it in, simplify for y, I get y equals negative 6. So my next point would be 2, negative 6. Then I could try 3. I plug it in, I get negative 3 for y. So my point is 3, negative 3. And I try 4. I plug it in, get my y, which is 6. So 4, 6 is my next point. And I could keep doing that as many times as I want, but that's good enough. I now have a good picture. I just connect the dots. I missed, so that's fine. All right, now it's a U, so I should have curved it out a bit. All right, so it looks a little better. All right, so that's how you can always graph a picture. Just plug in your x's, find the y's, and those are your coordinates. Now there's a better way of graphing it if you have standard form. So if you have y equals ax squared plus bx plus c, you can always find the y-intercept. The y-intercept has the property that x must be 0. So I plug in 0, that'd be a times 0 squared, which disappears, plus b times 0, which disappears, plus c, or just c by itself. The y-intercept is the constant term. We can also find the axis of symmetry by the equation x equals negative b over 2a. Now the axis of symmetry just cuts the picture in half. That's where the graph would be symmetrical, and it's of course a reflection. And the vertex is always on the axis of symmetry. The x term of the vertex is negative b over 2a. So you can always say the axis of symmetry is on the vertex, or the vertex is on the axis of symmetry. So if I find the vertex, the y-intercept, and reflect that y-intercept, I have 3 points I could graph my line. So for number 2, find the y-intercept, the equation of the axis of symmetry, and the vertex, then graph it. Well, let's do the y-intercept first. That is standard form. I see, well, if I plug in 0 for x, that this thing disappears, all that's left is negative 3. So I know the point 0, negative 3 is my y-intercept. So I'll graph that, 0, negative 3. Right, now I need to find the axis of symmetry or vertex, either one. I find that by doing the formula, negative b over 2a. So x equals that. So I do negative b, well, b is that 4, so negative 4 over 2 times a. A is the number in front of x squared, which is just 1. So that's negative 4 over 2, which is negative 2. I know my picture has this line of symmetry. X equals negative 2 is a constant line going up and down. So there's where my graph will be symmetrical. But let me find the actual vertex. I know the x point is negative 2. So I plug in negative 2 for x into the equation. So basically now I'm doing f of negative 2. I get negative 2 squared plus 4 times negative 2 minus 3. So do algebra. That's 4 minus 8 minus 3. That's negative 7. So I know my point is if x is negative 2, y is negative 7. So I'm going to graph that next. Negative 2, negative 7. Now remember, this is my axis of symmetry. It reflects the y-intercept. So if this is 2 from that, I'll count left. 1, 2. Here's my other point. It has to be exactly the same distance away. With those three, I can draw my parabola, my U. And that's the answer. Alright, next, there's what we call a maximum value and a minimum value for all parabolas. And the name actually says what it is. It depends on what a is on the quadratic term. If the number with x squared is positive, it's a regular U going up. And there is no top, there's a bottom called the minimum. And that's always going to be the vertex. If the number of x squared is negative, that means the graph is flipped upside down. It's the upside down U. It goes down forever, so it doesn't have a bottom, but it does have a top, which we call a maximum. Again, that's going to be on the vertex. That will be the y value of the vertex. So for the last example, state whether this quadratic has a minimum or maximum, and then find it. So we got to find the vertex, and then state the domain and range. When you do domain and range, graphing the picture will help you a lot. So first, I see that this number in front of x squared is negative. If it's negative, the picture is an upside down U. It's flipped. All upside down U's have a top, which we call a maximum. So this has a maximum. Now I got to find it. Well, that maximum is on the vertex. And to find the vertex, you do the axis symmetry, the formula negative b over 2a. So I'm going to fill that out. Negative b, that's negative 12. Over 2 times a is negative 4. So that is negative 12 over negative 8, which simplifies to divide the top and bottom by 4. I get positive 3 over 2. Or if you want to say 1.5, that's fine, same thing. Now that's my x. I got to find my y by plugging it in. So now I'm going to do the problem f of 1.5. So negative 4 times 1.5 squared plus 12 times 1.5 plus 18. For this, I will be using a calculator, so let me type that in. So negative 4 times 1.5 squared plus 12 times 1.5 plus 18, I get the answer 27. So I know this vertex top is a coordinate 1.5 for x, 27 for y. So the maximum is 27. Now they want me to find domain and range. Well, if you think about this on the graph, domain, how far left, how far right? The domain would be x goes left forever, negative infinity, and goes right for positive infinity, or all real numbers, your choice. Now the range, we're talking about how low to how high. We know it goes down forever. And the highest, the maximum is 27. And that does count 27, so there's a bracket there. So or here you could say y, 27, and y is less than or equal to 27. Alright, I'll end with this. Here's a practice problem. Do the same thing I just did. Find the minimum and maximum. And tell me what the value is. Then tell me domain and range. Again, graphing it will help you do domain and range. Alright, if you can do that, you should be fine for the quiz. Thanks for watching. This is Mr. Wynn, and I'll see you in class.